Welcome dear students. Today we are going to learn most important theorems and their proofs from our third chapter triangle. No one will ask you the proof to write in your exam, but we are using these statements in our further study of standard 10, and that's why try to learn it very carefully. And second proof is given as an activity. Learn that theorem also. Therefore, today we are going to learn the most important topic from our third chapter. The first one is perpendicular bisector theorem. Now, first of all, do you know the meaning of the word perpendicular bisector? When a line segment is given and when a line bisects that segment, passes through the midpoint of that segment and which is also perpendicular to that segment, that line is said to be perpendicular as well as bisector of the given segment. I am going to explain the word again. When a line passes through a midpoint of given segment and it is perpendicular to the given segment, at that time that line is said to be perpendicular as well as bisector. Bisector means which makes two congruent or two equal parts of the given line segment. Now we are going to learn the statement of the theorem, that what is given in perpendicular bisector theorem. Now when a point lie on a perpendicular bisector of a segment, that point is equidistant from the end points of the segment. Now observe the figure on board. Segment AB is given and line L is perpendicular as well as bisector of the given segment. Suppose we have taken a point P on that perpendicular bisector. Here you are going to prove that point P is at equal distance. That means in mathematics we call it as equidistant from the end points of the segment. Here we are going to prove that PA and PB, both the segments are congruent to each other. Now let us learn the proof. In given, they have given that line L is perpendicular bisector of segment AB. That's why here the angle is of 90 degree, sign of perpendicular is given as well as it is a bisector, and therefore suppose this midpoint is M. Therefore AM and BM are two segments are congruent to each other. Now in construction, draw segment PA as well as segment PB. Now here write construction, draw segment PA and segment PB. Now we are going to write the proof. In the proof, observe the figure on board. Suppose you are able to prove that the two triangles in the figure are congruent to each other, then PA and PB are corresponding sides of the given congruent triangles. Now observe the figure. Here in figure, this segment PM is the common side of both the triangles. Observe triangle PMA and triangle PMB. Segment PM is congruent to segment PM since it is a common side. Angle PMB is congruent to angle PMA, each 90 degrees since it is a perpendicular. Also AM is congruent to BM, and that's why by side angle side test the given triangles are congruent to each other, and therefore PA and PB are corresponding sides of congruent triangles. Now we are going to write the proof of this statement. Now in triangle PMA and triangle PMB, observe the figure. Triangle PMA is the first triangle which is a right angle triangle. Second one, PMB is the second triangle. The first one is segment PM is congruent to segment PM. The reason is common side. Next one, angle PMA is congruent to angle PMB, each 90 degree. Or since it is the perpendicular, it is congruent to each other. Now also segment AM is congruent to segment BM. This one is given. Since it is perpendicular bisector, it bisects the segment AB and therefore AM is congruent to BM, and therefore triangle PMA is congruent to triangle PMB by side angle side test. And since the triangles are congruent, therefore PA is equal to PB, corresponding sides of congruent triangles. Since PA is equal to PB, we can say that point P is at equal distance from the endpoints of segment AB, or in other words, P is equidistant from the endpoints of segment AB. Here we have completed the proof of perpendicular bisector theorem. Now we will learn the converse of perpendicular bisector theorem. It is given as an activity. That's why I am going to write the entire proof on blackboard, and then we will substitute the filling the blanks. Students, now we are going to learn the converse of perpendicular bisector theorem. But in our textbook, they have not mentioned that it is the converse. Actually, the statement is the converse, that when a point is equidistant from the endpoints of the segment, we are going to prove that that point lie on perpendicular bisector of that segment. But in our textbook, they have mentioned that it is the part 2 of perpendicular bisector theorem. That's why I have also not mentioned this is the converse, but actually the statement is the converse of perpendicular bisector theorem. Now observe the given thing in the figure. Now here they have given that point P is at equal distance from the segment endpoints of the segment AB. Therefore, the first given thing is PA is congruent to PB. Now here P is any point equidistant from segment AB, or in other words they have given that PA is equal to PB. In our textbook they have mentioned only that P is equidistant from AB. No need to write that PA is equal to PB. Now you are going to prove that if it is at equal distance, then P is on perpendicular bisector. No need to write the entire word perpendicular. Make this sign, that is perpendicular bisector of segment AB. Now in construction, first of all select midpoint of segment AB and join the point with that midpoint and draw line PM. This is our construction. Now we are going to substitute the filling the blanks. Now in figure also there are two different triangles, triangle PMA and triangle PMB. We are taking the same thing again. Side PM is the common side of both the triangles, and therefore all the three pairs of sides are congruent to each other, and therefore the triangles are congruent to each other by side test. And since the triangles are congruent, their corresponding angles are also congruent to each other. But this is angles are in linear pair, and therefore their addition is equal to 180 degree. But both the angles are congruent to each other. That means their twice is equal to 180, and therefore each angle is of 90 degree. In construction, we have taken the midpoint. Also, we have proved that angle PMB is 90 degree, and therefore point P lies on perpendicular bisector of segment AB. Since it is given as an activity, try to learn it carefully. Since in our question paper now, activity based questions are included, learn this theorem Now we are going to substitute the reasons. In triangle PAM and PBM, segment PA is congruent to segment PB. It is given. The first filling the blank is, it is given that PA is congruent to PB. Now the second thing, segment AM is congruent to segment BM. This is with the help of construction. In our construction, we have mentioned that PM is the midpoint of segment AB. Now segment PM is congruent to segment PM since it is the common side, and therefore triangle PAM is congruent to triangle PBM by side test. Now the next important step is angle PMA plus angle is congruent to angle PMB, which are corresponding angles of congruent triangles. Also they are in linear pair, therefore their addition is also equal to 180 degree. PMA plus PMB is 180, but both are congruent. That's why substitute in place of PMB, again write PMA. Since PMB is equal to PMA, I have repeated the name PMB. Now twice of PMA is equal to 180 degree, and therefore the single measure of angle PMA is equal to 90 degree. That means PM is perpendicular to AB. The first part is proved, and therefore by construction M is the midpoint of segment AB. Therefore P is on perpendicular bisector of segment AB. Students, here we have completed the activity which is actually the converse of perpendicular bisector theorem. We are going to learn the next important theorem, which is angle bisector theorem. You have already learned the concept that when a ray is said to be angle bisector, when due to that ray the angle is divided into two congruent parts, that ray is said to be angle bisector of given angle. Now in figure they have given angle PQR and QS is the angle bisector of that angle. Now on this angle bisector they have given that point A is there. On angle bisector they have given point A, and you are going to prove that point A is at equal distance from both the sides. This is point A. To determine the distance, draw perpendicular on both the sides, and this is point C. Now observe on blackboard. Here first thing they have given that ray QS is angle bisector of angle P, Q and R. You are going to prove that segment AB is congruent to segment AC. Now observe the figure on board. That is first one, angle PQR. Second thing, QS is angle bisector, and that's why these two angles are congruent to each other. Now we have taken a point A on that angle bisector, and you are going to prove that this distance AB, since you are going to determine distance, draw perpendicular on side QP of that angle. Also draw perpendicular on side QR to determine the distance between the angle bisector and the side. Now in figure there are two triangles. Observe those triangles. Triangle ABQ and triangle ACQ are both triangles. Now here both the triangles are right angle triangles, but here we are going to prove that how the triangles are congruent to each other. Now first thing, QA is the common side of both the triangles. Also these two angles are congruent to each other since QS is angle bisector. Also, angle B and C are congruent to each other since we have taken in construction that AB is perpendicular on QP, also AC is perpendicular on QR. And that's why the two triangles are congruent to each other by side angle test. This test is not mentioned in our textbook, but it is one of the tests of the congruency of triangles. Now I am going to write the proof. Here the first step is segment QA is congruent to segment QA, which is said to be common side. The next step, angle AQB is congruent to angle AQC given since it is angle bisector. Now angle ABQ is congruent to angle ACQ, each 90 degree, and therefore triangle ABQ is congruent to triangle ACQ by side angle test. Proof of this theorem is not included in our textbook. Also, no need to write it, but study from this board that I have mentioned the entire proof. Now the last step, therefore, segment AB is congruent to segment AC, corresponding sides of congruent triangles. Now students, here I have completed the entire proof of angle bisector theorem. Now we are going to learn the second part of the theorem, that is the converse of the theorem, where the position of given and to prove is changed. We are going to complete the next part, part 2 of angle bisector theorem, that is the converse of angle bisector theorem. That means a point which is at equal distance from both the sides of the angle is given. You are going to prove that that point lie on the angle bisector of that angle. That means indirectly you are going to prove that these two angles are congruent to each other. Now read the given statement. In angle PQR, AC is perpendicular on ray QR, AB is perpendicular on ray QP, and also AB is congruent to AC. That means point A is at equal distance from both the sides of angle PQR, and you are going to prove that point A lies on angle bisector of angle PQR. That means these two smaller parts of the angle PQR are congruent to each other. That is, angle BQA is equal to angle CQA. Now, if you are able to prove that these two smaller triangles are congruent to each other, then these two angles are corresponding angles of congruent triangles. Now both the triangles are right angle triangles. Now hypotenuse of both the triangle is a common side. QA is the hypotenuse of both right angle triangles and it is a common side, and therefore hypotenuse is congruent in both the triangles. Now we need another pair of side, that is, already they have given that AB is congruent to AC, and therefore these two triangles are congruent to each other by hypotenuse side test, and therefore these two angles are congruent to each other, which are corresponding angles of congruent triangles. Now I am going to write the proof. Angle ABQ is congruent to angle ACQ, each 90 degree. Also, segment QA is congruent to segment QA, which is common side. Now, also segment AB is congruent to segment AC, which is given, and therefore triangle ABQ is congruent to triangle ACQ by hypotenuse side test. Now, therefore, angle BQA is equal to angle CQA, which are corresponding angles of congruent triangles. Proof of this part is also not included in our textbook. No need to write it, but learn it and try to understand that what is given in the theorem. Thank you.